Thanks for joining our session. So today's session is about data and building intelligent applications from data. And I think everybody's mind is probably overwhelmed with information about infrastructure, CPUs, GPUs, networks, and storage. We're gonna go up the stack into the next layer, which is the data and how to make money with data, how to build intelligence, right? So to get started, there are a number of industry shifts that are dictating the product offering that we've created, which is the Tanzu Data Intelligence Stack. And what I'm going to do is walk you through what's happening in the industry. My name is Ivan Novick. This is Dan Basquette. We've been together on this journey for probably both about 15 years and helping customers to get value from their data with enterprise software that we have. So we're going to walk through what's happening in the world of data in the industry, give you guys a primer so that you're up to speed with the latest, and then what capabilities we offer, and then a demo. Okay? And all of that in like pretty quick timeline. So let's look at the shifts. So the first shift is the industry shift from focusing on thinking about cloud native to thinking about AI native. And what this means is that essentially that data is going to be at the center of your IT planning, because the AI use cases, the AI applications are going to be connected to enterprise data. And so instead of thinking first about the location, about, is it native to this cloud or to that cloud, we're starting by thinking about the logical structures and what information we need in order to build, agentic, intelligent use cases, right? So we're recentering ourselves around the AI use case, and by recentering around the AI use case, we're also recentering around the data, and then how do we bring that into real life in actual applications? Transaction shift is this explosion of availability of data. So historically, we might have had, transaction records and banking records, but now with the proliferation of intelligent devices, regardless of what industry or sector you're in, there are new forms of data, whether it be drone footage, biosensors, metric, things capturing, every time a door opens or closes, everything, and forget about everything that's on your mobile phone. Those are all a zillion different types of data metrics. So there is really an explosion of data. And so firms need to be thinking about how to be handling a wide variety, a high speed velocity, and a large volume of data, right? You don't just be saying, oh, I've got a network storage system or I've got a SQL server, I'm good. We need to be thinking more ahead about the types of data and how we're going to manage it. So how did people do this in the past and how are they doing it now? Again, this is a bit of a primer on the industry for data. But if you go back to 2005, most data was structured and the go-to answer was build a data warehouse. So data warehouse was the go-to answer. Take some of the names on the whiteboard here. But that became highly performant for querying the data with SQL, but it also became a silo. It became a expensive silo that would meet certain use cases, but was kind of not open to building new use cases. And what people then yearned for was more access to the data, more elasticity, which led to the data lake. And the data lake came in 2000, it kind of peaked in 2015. And the data lake would give you very elastic ability to store all kinds of structured and unstructured data. But unfortunately, it became frequently affectionately known as the data swamp. Because just because you have a place to put everything doesn't mean that it's structured and organized like in your closet where you go in the morning and you get what you're looking for, right? So the Hadoop phase did slow down and did kind of transition. And essentially what resulted out of that is a new phase of lakehouses architecture. And the lakehouse architecture borrows from the extremely scientific and high performant nature of the data warehouse, as well as the elasticity and openness of the data lake to create a lakehouse architecture using primarily two interfaces, SQL for querying, and then Apache Spark for doing in-memory processing and ML. Or equivalent things to Apache Spark, but Apache Spark is pretty dominant. Another trend that has happened is this emergence of PostgreSQL as an industry standard. Because of the license, because it is 100% free, and not only is it free to users, but it's free for companies to modify, redistribute, and build new products on top of. It has created a proliferation of adoption. Many of the world's most popular data services are based on PostgreSQL or derived from PostgreSQL. And you'll see enterprises adopting Postgres at scale. So this is another really important trend. And then the next trend is the transition from batch to live action. So gone are the days where it was sufficient to have your data analyzed offline and then show up on the weekly report or the executive dashboard, right? Being on an executive dashboard means somebody is going to go and look into it later and think about what they want to do with that. The modern approach is to have your analytics and your intelligence feed directly into live business processes. So the idea is that as data is being analyzed, it's changing the course of your business or your government activity through software, right? And that's really an important shift. And then another really important shift is the adoption of data cataloging. So as the explosion of data sets and types of data and data systems and hybrid systems, lakehouse, combining lake and warehouse, combining private cloud and public cloud or bare metal on-prem cloud, how do you track all this? How do you govern all this? So although a specific database, let's say Oracle, has its own catalog, how do I have a catalog across all my data sets? And then how do I use that catalog to find information about data and to track the data and to govern the data? This is an important trend. And then very subtly, importantly connected to that is, even if I have all that data and if I want to build an application, let's say I'm running a railroad and I want to build a application to help the ticketing system to give out special offers, I'm not going to let them hit my data lake with my data intelligence. I'm going to want to automatically populate that into a cache. And so how do I take sub data sets from my catalog and expose them to applications without opening a Jira ticket and negotiating between teams? Hey, can I copy some of your data to my database, right? How do I just pop it up in an easy to access development framework? And then when we talked about real-time event business decision processing, this is again an important trend, which is how do we take transformed, enriched data that's been generated by combining data sets in a data warehouse or a lakehouse. It's been aggregated and enriched, and then create it into an event stream and have activity happen based on those event streams. So if I'm going to see that a flight was delayed or that a passenger was upgraded or that somebody canceled their ticket, what automatic processing will I do through manual coding based on rules or through an agentic application where you have a dedicated agent, software agent built for a specific purpose to handle flight delays, for example. So moving to event-based processing. And then SQL really was mathematically designed as a perfect language to query data, but it became a little bit too hard for just too many people. That an entire industry was created called I'm not SQL, AKA NoSQL, right? So how many industries or products do you know of that start with the name no, besides NoSQL? So they must have done something wrong, but really SQL was designed perfectly for selecting data as a set theory, as relational algebra. But now with AI, that little bit of friction is gone because it's very easy for any business analyst, any employee in the firm to ask a question and have it automatically converted to a very, 5,000 line SQL query. They're off to the races, and SQL is the perfect language to query. So this is a perfect trend which brings back SQL as the dominant force of data querying. So in Tanzu, where we come in to put us into place is you've got your VMware Cloud Foundation, which is your private cloud, and then we have the advanced services. So where we come in is on the AI services, the application services, and the data services. And at Tanzu, our mission is to drive business velocity by accelerating your ideas, business ideas, into the code and the code into production, and to do this really without putting too many layers of IT in the way. And so in our team, under the data intelligence, historically, we are known for some of our core brands, some of our successful brands. So GemFire is a brand for real-time, sub-second, in-memory grid. Greenplum is a brand for data warehousing. We also have RabbitMQ as a brand for messaging. But what we've done and announced in this conference is the creation of the VMware Tanzu Intelligence Fabric. And so this data intelligence fabric is a modernized approach to build an end-to-end system that can capture the value of all these trends that we just talked about. So with these trends coming in, with the shift from dashboard to real time, the shift from the ability to write extremely powerful SQL, the shifts for event streaming, all of these trends need a modern data intelligence platform for you to be able to build your solutions. And yes, we are a software-based portable solution that runs in different environments, in colos, on private cloud, in hyperscaler clouds. But really, as part of Broadcom and VMware, we're here to really support our VMware customers to also get this experience on the private cloud, which there's been less options historically for data intelligence on the private cloud. And so when we look at some of the basic principles again, so let's start with this idea. SQL is the way to query data. It's the set theory that says how to chop, slice, dice, aggregate data. Postgres is the free and open source standard of how to do that. The problem is, what do you do when your Postgres keeps getting bigger? So you get from 1 gigabyte up to 1 terabyte. You're not going to find a VM eventually that is big enough. You're not going to have a petabyte VM. We need to shift to a horizontally scalable architecture. And so Greenplum is that Postgres-based horizontally scalable architecture that gives us SQL query access. So it gives us, at the foundation of data intelligence, a relational engine to run SQL at massive scale based on the industry standard Postgres database engine. And then combined with that, as we embrace the lakehouse architecture, is the Tanzu Data Lake component, which is derived from the last 20 years of amazing research in the Apache Foundation on what I would call the Apache Hadoop ecosystem. Now, we do have a large components of Apache Hadoop ecosystem included in Tanzu Data Intelligence, but not all of it, and it's very opinionated. So when we look at it, we say, what is the key aspects that make a lakehouse? Open table formats. Open table formats mean not only am I storing data in files, the files are optimized for high-speed scanning, but they're open. But not only am I storing data in files, I have a bigger concept of a table where I can link hundreds or thousands of files into tables and have transactional semantics like a database on top of them. So that's where Apache Iceberg comes in. And Apache Spark is the in-memory compute that if I'm not trying to do a query, right? If I'm not trying to say, tell me this, select this information for my data set, I want to compute something, that's where the industry standard tool right now is Apache Spark. I want to compute a machine learning model, and I want to build some predictive analytics. So in a lakehouse architecture, you have both the high-speed SQL query interface and the in-memory compute with something like Apache Spark. And then with that, we have the data catalog. So what we have is the open metadata-based data catalog that allows us to track and store everything across the lake and the warehouse and even external sets in order to see a single view of that data. So then together, what you have is the concept of the lake house and the key principles of the lake house architecture, which is that SQL, the open table formats, the in-memory and ML processing, and the metadata and the catalog. This is the core structure that creates the lake house. Now, all of this is tuned and pre-engineered to be running on VCF as a first-class citizen. VCF would be our ideal choice for a customer because We've seen here this week how much investment is being done on that platform. But if you want to vary that, the data intelligence platform is a software solution. It is an open standard. So of course it can run on a myriad of different platforms. But we spend a lot of time kind of testing and benchmarking VCF as our tier one, preferred choice based on all the investment we're doing in the company at Broadcom. So what this lakehouse architecture looks like is a range of hot data, warm data, cold data, where you will store data that needs to be frequently updated, or data that is queried on a very rapid basis in the hot section, which may be indexed in various different ways, and that could be queried at very low latency. And then you move down the tiers to lower cost storage, maybe for archive data. Maybe you have 10 petabytes of data you're also querying, but you want to make sure it's available for SQL query, but it's not necessarily running up the same amount of cost based on a lower kind of storage tier. And then all of it gets queried through a single interface. Your analyst, your data scientist can run a query. If they're using an LLM, they're asking an English language question or a language question, converting that to SQL. SQL is running across the entire ecosystem, giving back your very efficient data. Now, we do include some legacy migration tools. So if you're running on, let's say, a Cloudera or a Hortonworks Hadoop cluster and you want to migrate, we do provide an inbuilt tool that without copying your data, we can migrate that solution into Tanzu. And in addition to that, we provide data ingestion services. So we really provide the end-to-end from data ingestion, processing, querying, computation, and then providing it as data streams and caching for applications for real-time decision-making. So the data flow is this concept of processing data as a data stream, right? And so this is, again, back to the use cases we had in an airline. A flight was delayed. Now that event comes through. So we write some Spring code, we process that, and then we go to the next stage. Somebody canceled their flight. Okay, what are we going to do now? So we go from data to data processing to action to code to outcomes to business outcomes. And that all runs based on RabbitMQ as a stream. And before I go to real time, what I'm going to do is I'm going to pause, and we're going to do the demo. And then after the demo, I'll show you a little bit more of what's in the bag.
All right. All right, so what I wanted to do was build a typical application you might see in the wild that leverages as much of the data intelligence platform and also the Tanzu platform on the back end. So here, everyone's probably seen the commercials from Allstate, Progressive, right? Install this app on your phone, maybe get car insurance discounts, right? So how are they doing that, or what are they doing? Well, in this case, they're basically generating telematics from your phone. So I built a generator that generates the same kind of data, but they're getting XYZ axis, speed, GPS coordinates, vertical height of your phone, lots of other telematics coming through that. And so in this case, we're putting that data into RabbitMQ on Tanzu Dataflow. And at that point, we have what's called a fan-out exchange that goes to two different queues. So one will go to HDFS because it's a great place to store terabytes of long-term, in this case, JSON records, stored as Parquet. And so that's one path. The other path goes to an in-stream processor, which is actually going to watch those records as they come through and look for high G-force events, which might be an accident. Because those same apps that are sending the telemetry data, they also will enable insurance companies to send you a note if they detect an accident to find out if you need to file a claim, make sure you're okay. So in that case, we're taking that data, we put back into Rabbit as a different queue, and we'll then send those records into Greenplum on the back end, and then the log sync there is basically representing some process to maybe SMS the customers. So how does this all come together? Well, at the end, they can take that data, and since they have access to be able to query via PXF that Ivan talked about, and then they have access to the accident data and all the customer data. We can now do like a machine learning inside the database. So we have MATLib libraries to run machine learning inside the database. In this case, I've built a regression based on these weights, which then can generate us a driver score based on what the driver's doing. So in this case, if we see harsh events where you're using your brakes and changing your speed rapidly at stop signs, we can tell if you're using your phone based on how high it is over time. And we generate these driver scores, which in 6 months when your insurance comes back up for renewal, they'll use something like this number to generate your rate quotes, right? If you got a good driver score, maybe it'll be a lower one. Or in this case, if you have a lot of phone usage while you're in the car, you're speeding a lot, then you're going to get a lower driver score. So all that running on Tanzu platform enabled by Tanzu Dataflow. And the nice thing about Tanzu Dataflow, the more data that comes in, we can automatically scale those processors in sync because they're just getting data out of a queue. So I can have one or I could have 1,000 of those processes all running and dumping the data in. Right? And I'll have another one at the end.
Yeah. Okay, so let me do the other bit, and then we'll do the other. All right. So you can switch back.
Yep.
So thanks, Dan. So that was a little demo showing the data flow with Greenplum, with Rabbit, with machine learning. But the next aspect that I want to talk about is caching. So in the industry in general, there's been a lot of success in big data platforms. We talked about data warehouses and data lakes. But when you go and build a live application, let's say something, for example, to buy tickets online to an event or anything that has a public interface, a website, an app on the phone, you could be having millions of people accessing it in real time. And it's really, data lake houses and data lakes and warehouses were not designed for that, right? They're designed to have, let's say, instead of 1 million people, 1,000 queries running in parallel, but not 1 million. So as an application developer, Tanzu, we're making it easy for people to take data from their big data and their lakehouse environments and expose that as an application cache. And so we have 4 different engines that are quite suitable for caching, even more engines. Even Greenplum can be thought of as a cache in certain contexts. But we take one of our databases, let's say GemFire, Postgres, Valkyr, MySQL, and basically by creating event streams, we can have data sitting in these caches that are up to date and that you could build your live application based on. So when we look at one of the new capabilities for Greenplum, which is under consideration for the next release, is event emission from Greenplum. And so the idea is that as Greenplum is updating data and events change, it's emitting essentially open format JSON saying, for example, here, the order was updated. Here's the timestamp. Before it was pending. Now it's been shipped. As these event streams go into a message buffer, a topic, then applications like data flows can be processing those and doing business processes. Okay, it was shipped. Now what am I going to do? So we talked about caching and event streams, but back to caching, what we provide in Tanzu is a globally available active in-memory grid. This is pretty unique because there are very few systems out there that provide active, meaning across 3 centers in the world, I'm updating the data in real time with sub 1 millisecond latency because it's all in memory, and with the scale of being able to handle millions of concurrent accesses. So this part of Tanzu, which is named GemFire, gives you this global in-memory grid to buffer and support the extreme scale application workload. There's a few different topologies if you want to know how the data how it works and how the data is kept safe. One topology will be a zone-based topology where you're within, let's say, a local region and you're having synchronous copies, guaranteed in real-time synchronous copies of the data in different zones. And then another topology will be around the world asynchronous. And this will be, all of these are active, but in this case, the asynchronous case, there'll be conflict resolution to ensure that if I update data in New York and Tokyo, that it's being resolved on both sides with conflict resolution. And then one of the latest trends is to vectorize your unstructured data. So in this example of a new capability, what we do is we combine your structured data. For example, in this example, I'm a shipping company. And so I've got structured data about what boats have left the port and what time they left, what they were carrying in their container workload or in their ship workload. But I also have the photos and drone footage of the ships. And so the idea is, as I'm taking drone footage, I'm recording that and I'm passing it through an LLM or an embedding model to convert this drone footage into 1,000-dimensional vectors, which essentially gets stored with the lakehouse along with the rest of the data. From there, application developers can build real-time applications that query that, and they can search and say, hey, I'm searching for boats that meet this description. We'll pass it through an embedding model and do a similarity search for that embedding model, and then filter it and join it with other conditions in the data lakehouse. And you've got this multimodal type of intelligence that you're building that can understand drone footage, radar, LiDAR, plus your data, and you really create the full data understanding of the world around you from a business point of view. Kind of as a quick flash, I wanted to show you a screenshot before we get back to the second demo of the metadata catalog. This is a screenshot of the metadata catalog, and it will show you, for example, different tables and annotations about that you have about the data. You can tag, label, and annotate it, so when you're building your application, other people can find those data sets. And then machine learning. So we talked a little bit in the insurance megacorp example about building the ML models about how good a driver you are. How do you build that ML model? We have an agent that you can work with, a software agent to work with to find what that model looks like and to try many different experiments and help you build that model. So there's about 20 famous models that are out there. We test them all through experiments, run little micro experiments, and then give you a tooling to help you come out with the best option. And one more kind of crazy kind of a question, you can say you can ask very complex questions now that you've combined structured and unstructured data, vector data. In this example, we say find everyone connected with John Doe LLC to the third degree whose name sounds like Peter or Pavan, has filed tax returns for a refund for more than $2,000 within this time frame, and has this address. And you can see it combines graph query, NLP query, sounds like query, geospatial, ML classification, and OLAP queries all in one sentence. And you can even use English to pass that through SQL generation and have the system come back with that data. So let's do the other demo.
All right, I guess you're not in a conference session until you're seeing something involving AI now, right? Everything has to be AI. So in this case, sort of back to that insurance megacore, really they want to be able to take the policy information. So everyone gets the policy declarations when you get insurance policy. 20 pages of legal mumbo jumbo. It tells you all the rates, how much coverage you have. Right, but there's always a lot of call center volume, people asking questions about that. So in this case, we want to take those policy declaration documents, send those through a process to embed them into the vector database, and then provide sort of real-time access for customers who use natural language to get access to that data. So in this case, we're back to Tanzu data flow, and we implement this as a couple different modules. So there's a HDFS watcher, so it's looking at the Tanzu data lake, and basically a dumping ground for all that policy or any other information we have in PDF format. Then we have a text processor. So this is written in Spring AI. And what that's going to do is take those PDFs and turn them into text documents so that they're easier to vectorize. Then we have the embeddings processor, which takes those text documents, embeds them, and puts them into the vector store. So just for an idea of what sort of the vector store looks like. So you can see here, this all lines from your declarations document. And when we talk about vector stores, That's what we're talking about. So some number like 128 different vector coordinates that give you a point in space, so that when I do a natural language query, I'm trying to find points that are closer to that. So in this case, if you're asking about something around like how much I have to pay out of pocket before insurance kicks in, right? It's going to look at all the words around that and figure out, hey, he's talking about deductible there, and then be able to answer that question. Or if I do just a native text search, if I ask something very open-ended like that, how much do I have to pay before insurance kicks in? It's never going to find you an answer, right? So a typical chatbot is never going to be able to answer that. But when you use vectors to find that information, then we can answer that, and that sort of turns into something like this. How much I have to pay out of pocket in an accident. It can check the policy, and then it knows, hey, these are your deductibles. This is exactly what you're going to have to pay. All right, and we surface that through leveraging MCP, so Model Context Protocol. It's a client and server technology in the AI space that allows you to provide tools to an MCP client that an LLM can use. So in this case, customer asks a question, it goes to the chatbot client, it sends that question to it'll do an embedding, it'll send the question to the LLM. The LLM will say, all right, do I have any access to any tools that can help me answer that question? And it says, oh, okay, I have anything they're asking about policy info, yes, I have a tool. So the LLM will call the client, who then goes to the MCP server, he'll do a vector search, pull back all that information gets passed to the LLM, and now the context is, how much do I have to pay out of pocket? And then you have all that information from your policy that it has, and it'll answer the question out of that context. And so that's how you get the real answer, and pass that back to the web clients. So all that running Tanzu Dataflow for scalability, PG Vector and Postgres on the back end, and Tanzu Platform providing the LLM. All right.
Okay. Let's go to the. So thanks, Dan. So they say people who live near snow can have a word for 17 different types of snow. So data is the same way. We've got words and techniques for 17 different types of data, but all of that is covered by Tanzu Data Intelligence, and it is geared for the private cloud. It is geared for VCF infrastructure. So when you're working with a client, or you are a client, and you want to deal with the future requirements coming in for the new world, right, of AI, we're going to go beyond AI, right? Every trend lasts 7 years, and then there's the next one. So we're going to go from AI, we're going to go to physical AI, we're going to go to robotics. Who knows where we're going to go, but it's going to have gazillions of data, right? And so you want to have a data stack that can handle all the 17 different types of data in as many different ways as possible. You can sort it, filter it, organize it, query it, use natural language, mix and match. So that's where Tanzu Data Intelligence fits in. We'll be around here the rest of the day. If you have any questions, or if you want to kick the tires at your client site, let us know. But thanks for joining the talk, and hope this gave you a quick insight into what we offer. Yep.